examples for Lenz's law. If this is conductor carrying current, this is the loop. We want what is the direction of induced EMF, induced current in the loop. Find direction of current in loop if magnitude of I is increasing. When this current flowing through the conductor is increasing in nature. So can I say field on left hand side will be in inward direction and increasing in nature? Can I say like this? Therefore, field B bar is inward and increasing. Can I say this or not? Hello, can I say this? मतलब ये coil का साथ field will be inward and increasing in nature. Not followed this much?
Yes, sir.
Yeah. So field is inward in nature and increasing. According to Lenz's law, induced current should oppose the nature cause producing it. So increasing ko it should decrease, isn't it? By Lenz's law.
Yes.
So inward will be decreased by whom? Outward or inward? Inward vector. If I have to decrease, I have to apply opposing vector.
Okay.
So inward will be decreased by whom? Outward or inward?
Outward.
Outward. If outward field means current should be in anti-clockwise direction. Okay.
Yes, sir.
Outward means anti-clockwise. So we want, they can ask you what is direction of current due to this condition. So current here induced will be anti-clockwise direction. Any doubt? Any doubt in the first example?
No, sir.
Okay, just copy. Few more will do so that you understand perfectly how we can apply Lenz's law. Do first one.
Done.
Yes. One more will see. A conducting rod metal is made to go inside at one position and moves outward from second within this field. We want what is the direction of current in first and second coil. At position 1, coil is entering in the field. That means field is inward, but it will be increasing because coil is entering. By Lenz's law, it should be decreased. Inward is decreased by outward. So current at position 1 is anti-clockwise. At position 2, coil is leaving. Therefore, field is inward, but it will decrease because coil is moving away. Decreasing should be increased by Lenz's law. Inward is increased by inward because they add. Therefore, current will be in clockwise direction at 2. Both followed?
Yes, sir.
Yes, sir.
Yes, please now do it.
Done, sir.
Next study, motion of a straight conductor in uniform magnetic field. Motion of straight conductor in uniform magnetic field. EMF developed is called motional EMF. So they can ask derive expression for motional EMF. Suppose this is one conductor having length L to be moved in a uniform magnetic field of induction V bar, which is perpendicular but inward with velocity V. Just draw this diagram.
Done, sir.
Okay. Now, can you tell me, because it is conductor, it will contain free electrons? What will be the direction of electrical force? Now, here there is first magnetic force. What is direction of magnetic force? When charge Q enters in magnetic field, then it experiences magnetic force given by QVB. Direction is given by Fleming's left-hand rule. Field is inward. Motion is toward right. Force is upward if it is positive charge. Because it is negative, it will act downward. Magnetic force will act downward.
Yes, sir.
So this electron will come and get deposited towards this lower end. If I call this as P, this as Q at lower end. Correct? This electron will get deposited towards lower end.
Yes, sir.
So this will become positively charged because some electron नीचे गया, ऊपर positive charge develop हो जाएगा. Because of this positive negative, there will be electric field from positive to negative. Electron will be attracted by electrical force Fp. When electric magnetic force balances each other, then motion of electron will stop. But there will be potential between the two ends called as motional EMF. Because of motion of conductor, we are getting EMF. So again, I'm repeating. Understand first. Consider a conductor वो नंबर स्टोर नहीं है. हाँ 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 गौरव जी बोले मैं उस दिन मैं पूछ रहा था संतोष से कि आते हैं कि नहीं, तो बोले नहीं वो 5 बजे आते हैं. मैं अराउंड 7:38 के आसपास आता हूँ. नहीं इवनिंग में. आप कभी आते हो? अच्छा 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 अच्छा. हाँ ओके ओके. अच्छा अच्छा. मेरा तो क्लास मुलुंड में है ना, अपना जवेर रोड पे कालिदास के वहां. मैं आज इवनिंग तक बता था. इवनिंग तक मैं आपको नंबर दे दूंगा उस सर का. खाने में ही रहते हैं, फिर आप बात कर लेना उनसे. हाँ 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 मैं स्टोर कर लेता हूँ. यस करो. यस 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 श्योर श्योर. Consider a conductor of length L to be moved with velocity v perpendicular to magnetic field P bar, which is acting inverse. So consider a conductor having length L moving with velocity v perpendicular to field B, which is acting inverse. Just copy this much. Draw diagram में negative minus magnetic force downward, electric force upward.
Sir.
Once, after this. Diagram drawn, no? So that I can clear everything.
Yes, sir.
As conductor contains free electrons, they will also move with velocity v and experiences magnetic force Fm equal to EVB experiences magnetic force EVB and moves towards lower end of conductor. Hence, lower end becomes negatively charged and upper end becomes positively charged. Thus, electric field E is developed from positive charge to negative charge. Okay, please copy again till this. Due to magnetic force, electron moves towards downward side, therefore it is negative, up is positive. So there is electric field developed from positive to negative.
Done, sir.
Thus, electric force acts on electrons in upward direction at certain value of E. The motion of charges stops. Hence, at this condition, EBB equals to E into E. Therefore, V equals to E equals to velocity V into V. Since potential difference across conductor of length L, comma V equals to E into L. Therefore, E is VB into L. Therefore, V is VLV. So, potential across conductor when it moves with velocity V is given by VLV. Completely right. So, for moving rod or moving conductor, voltage or EMF induced is VLV. One formula of EMF induced, general d phi by dt. For moving conductor or translating conductor, VLV.
Done, sir.
Motional EMF in rotating conducting rod. One was translating, this is in rotating a conducting rod in uniform magnetic field. That means this is suppose a conductor pivoted at point O, length is L. It is rotated in a uniform magnetic field of induction V bar, which is perpendicular but inward, is rotated and brought to new position Q. Let this angle be d theta. So what will be this arc length? Can I say L d theta? Radius into angle is called arc length L d theta. Okay?
Yes.
Okay, just copy this much. A rod OP of length L is rotated with angular velocity omega in uniform field at position PQ. If angle of rotation is d theta, arc length will be LD. Can I clear?
Yes.
Consider a conducting rod of length L rotated in a uniform magnetic field of induction P bar about point O. Hence, angular displacement be d theta in time dt second. Therefore, area swept by conductor comma dA is half into length of arc, which is PQ, into radius OP. See, area is half into length of arc into radius. You know this formula? Half LR is area of sector.
Yes, sir.
So that will become half PQ. We got d theta L d theta into radius is L. So that will become half L square d theta. Okay.
Yes.
Copy this much again. जो कॉल रखे थे आए क्या? अच्छा टाटा मोटर 475 में क्या होगा? हाँ अच्छा वो बाकी सब निकाल देना, ये ले लेना है। हाँ चलो आ गया। 25 में रखना। Completed?
Yes, sir.
Rate of change of magnetic flux linked with rod is given by d phi by dt, which is p dA by dt. That will become v into dA half L square d theta upon dt. What is d theta by dt called as? Angular velocity.
Yes, sir.
Yes.
So b half L square omega. This means EMF induced is half b L square omega. Right now. Copy. Thus, EMF induced comma E equal to half b L square omega. So one formula is general d phi by dt. Moving rod BLV, rotating rod half BL square omega, rotating coil E0 sin omega t.
Done, sir.
नोट कर लो फॉर्मूला सब साथ में so that you remember. E is d phi by dt. One formula for moving rod. E is BLV. Third, for rotating rod, E is half BL square omega. For rotating coil, E equals to E0 sin omega t, where E0 equals to NAB omega. Copy this much. Then next topic I am starting.
Done, sir.
Eddy currents. Eddy currents. So eddy currents are induced current, and whenever we want induced current, that means there should be change in flux associated. To have change in flux, either I can change the field, that means I can rotate the magnet, or I can have the conductor rotating in the field. In both cases, flux will be changed. So when a conductor in the form of solid metal, not in wire, but solid metal, is rotated in a uniform magnetic field. When a conductor in the form of solid metal is rotated in a uniform magnetic field, hello? Yeah. Pardon? When a conductor in the form of solid metal is rotated in a uniform magnetic field or placed in rotating magnetic field, either rotated in uniform field or placed in rotating magnetic field, then current is induced in the metal which are like eddies in water called as eddy current. That means in still water, when you drop stone, concentric circles are formed. Those are called eddies. Or if water is flowing, if somebody places one wooden rod in between, तो water ऐसा ऐसा घूम के जाएगा. That is called eddies in water. Are induced, which are like eddies in water, called as eddy current. They were first observed by Foucault, hence also called as Foucault current, right? Hence also called as Foucault current. चलो बैंक निफ्टी 37,000 का कॉल. कितना? uh, 172 में रखना. चलो डन.
Yes, sir.
See. So eddy currents are those currents which are actually induced in conductor in the form of solid metal. Now disadvantages of eddy current. Disadvantages of eddy currents. See, eddy currents are produced in a conductor which are like solid metal. Hello? हाँ, ठीक है. Disadvantage of eddy current. Eddy currents, they are generally developed in the metal. So this is suppose core of transformer. Here you connect one coil. Then this is alternating current flowing. This alternating current will develop changing flux. So there are eddies developed here. Eddy current is a goal. Because electron has got the space to move. And whenever there is current, there will be always heat. So I can say eddy currents produces large amount of eddy currents produces large amount of heat in core of transformers. Core means support of transformer, comma generators, which when not avoided can damage the coil. Which when not avoided can damage the coil. It can be minimized. It can be minimized. Means you can't make it zero, but you can make the effect minimum. It can be minimized by using transformers, comma generators having cores made up of bundles of thin rods insulated from each other, having high resistivity. So instead of having single cylindrical support, we are having many rods joined together. In between we put insulators. Thin rod insulated from each other, having high resistivity. Resistivity high, current will be less, heat produced will be less. Copy this. Disadvantage and how it can be minimized.
Done, sir.
Advantages of eddy currents. Advantages of eddy current. First, dead beat galvanometer. See, dead means मर गया ना. So when no current passing मतलब dead होता है कोई भी चीज. Beat मतलब उसके बाद मारने वाला है. Galvanometer, you know, it gets deflected when current passes. So in coil of moving coil galvanometer, when current flows, then this coil gets deflected in uniform magnetic field. When current flows, this coil will get deflected. Hello?
Yes, sir.
And when coil gets deflected, that means this aluminum and copper frame on which coil is mounted, that will get deflected. Correct?
Yes, sir.
Now when this metal is getting deflected in uniform field, then that eddy current will come inside this, which is
Yes.
opposite to cause producing it. Matlab, if it is moving anti-clockwise, it will try to push it clockwise. But till main current was present, this eddy current value is not sufficient to bring it back. But moment this current is stopped, that means galvanometer is made dead. So ये eddy current मार के उसको पीछे लाएगा फिर से opposite direction. Means it brings it back. तो हम लोग बोलते हैं it makes the galvanometer dead beat galvanometer. It won't oscillate about this point. ये इसको पीछे लाने में मदद करता है easily. That's why it is called dead beat galvanometer. Dead means when no current is flowing, then the effect is coming. Are you getting meaning?
Yes, sir.
In the metal frame of moving coil galvanometer, eddy currents are developed when coil gets deflected. But when main current is stopped, then eddy current will help it to bring back to the original position instantly and makes the galvanometer a dead beat galvanometer. This is one of the advantage or use of eddy current. Right. Dead beat galvanometer. Heading right, then I'm clearing. Heading written?
Yes, sir.
When current is passed in coil of moving coil galvanometer, then coil gets deflected in uniform magnetic field. Hence, metal frame gets deflected in uniform magnetic field, and eddy currents are developed which opposes the motion. Thus, when current is stopped, then the eddy current helps to bring the coil back to the original position, which almost instantly. Yes, copy this much.
Done, sir.
In the original position almost instantly. One more line. Thus, it makes galvanometer the galvanometer a dead beat galvanometer. Second one, induction furnace. Induction furnace. To make alloy, we have to melt the metal. Correct? To make alloy, two metals must be melted and then mixed together.
Yes, sir.
So to melt, we require heat. So induction furnace, it consists of coil wounded on furnace. When alternating current is supplied, then changing magnetic flux gets associated with the metal. Now it produces heat which we require. So it is advantageous. Eddy current now produces large amount of heat in the metal, which is sufficient enough to melt the metal and forms alloy in industries on larger scale. That is one of the use. So in industries, to make alloys, induction furnace is bounded with the coil connected to the alternating source. Hence, changing magnetic flux is developed, which produces large amount of heat in the metals to be melted so that they can be utilized for useful purpose. So second one, induction furnace. In induction furnace, which is bounded with coil when connected to alternating source, produces eddy currents in the metal kept in furnace, and large amount of heat is developed, which is helpful to make alloys in industries on large scale. Right. Just two uses you can study in detail. Two more I am telling, but only headline will understand.
Done, sir.
Third one. It is used in electric brakes. That means to stop this electric trains or locomotive, driver first put off the supply so that train cannot be pulled further, and then applies alternating current between the axle in the drum on the axle. So when eddy current is produced, it will try to oppose that motion due to inertia. So train will come to rest almost instantly. That means if this is EMU, electromotive unit, connected to this pantograph, if you have seen properly, this keeps on sliding and it keeps on moving. So driver will put off the supply, so ये train को pull करने के लिए force नहीं मिलेगा. But due to inertia, it will keep on running for certain distance. So simultaneously, to stop the train instantly, इधर एक drum रहता है above the axle. Axle means rod connecting to wheel. Here he applies electric current, alternating wala, which produces eddy current in the rod, and eddy current is always opposing the motion because it is induced. So it behaves like electric brake and train comes to rest almost instant. Fourth, it is used in speedometer. Mostly in vehicle, there is one device called as speedometer to check the speed. So Beside that, there is one magnet which runs with the speed of that vehicle. छोटा magnet है. So वो magnets के बीच में there is coil. So coil is placed in rotating field. Eddy currents are produced. This deflection depends upon speed, and hence we can measure that speedometer, the speed. So 4 uses: deadbeat galvanometer, induction furnace, electric brake, speedometer. So in MCQ they can ask which of the following uses eddy current. So if you know the appliances, you can mark the correct option. Completed?
Done, sir.
So today we'll stop here. Next class will complete what is self-induction, mutual induction, then some derivation based on that self